All right. This is where a function is not differentiable. In other words, the graph of the derivative is not continuous at certain points, and we want to know what point is that on this graph. So I have a green graph here, which we will call, so f of x is green. Okay, now what we're going to do is graph the derivative in this pink color here. Okay, so f prime of x will be pink. So it really sticks out. All right, so we know something about the graphs of derivatives, that it's all composed of slopes of tangent lines of every point on this green graph. And we also know that a tangent line is the result of a secant line. Just an example, I'm going to erase this, but just watch. If you take this point and connect it through there, that's called a secant line. It's good to review this stuff. Well, if I start shrinking these 2 points, if I start taking limits of putting these points infinitely close together, well then imagine this pink dot riding along right up through here, and this pink dot coming up through here until you make this point. This is called a tangent line, and that is the whole idea behind a derivative. Eventually, there we go. Okay, so that's what we're doing. So let's go left to right on this thing and make a graph, and then we'll talk about where the function is not differentiable. Well, it appears that this green line, starting from here and cruising down to here, is straight. I mean, I drew it with the straight line tool on this, and it looks as straight as you can get, which means its slope's going to be constant all the way through. So I really don't need to make tangent lines all the way down through here. We just need to figure out what we think this is. So if I just theoretically extend these points out here and I count, slope, which is down and right in this example, or up and over, this is going to be a negative slope. So if I go from here, say down maybe, 2 over 1, something like that. That looks pretty good. Down 2, right here. Down 2 over 1. We could do that with a triangle if we wanted. I don't think that's necessary, but that's how slope works. Get rid of that so I don't confuse my drawing. I'm doing this on a different layer so I can get rid of all this so we can see the original when we're all done, because this is going to be quite a mess when we're doing it. But this is 2. This slope is about 2. Which means for my derivative graph, it would be this point here, this pink point, would be down to 2. Now I'm behind this little thing. Here we go. So maybe right there. And then at point -5, this other pink dot on here would be also the slope of that point right there would be 2. So we got here. And the slope of this point would be 2. And this point, still, remember, we're talking about the slopes here. That slope of that tangent line is still 2. So we're here at 2, we're cruising around, and we're here, right down in here, it's still 2, but then something weird happens. Okay? Then the game changes. So from right here, we'll put an arrowhead here, because that's assuming that that's going to be straight. It goes to right here. Now that's a straight line. Let me make that a straight line so it doesn't look kind of messed up there. Let's go from here. We'll make this look as good as we can. There we go. So that's straight. But here, this graph is like joined together, and this here is called a cusp, C-U-S-P. That point right there. And it's because it comes down. Now, if it didn't have a curve to it, if it was like an absolute value graph and came down like into a V, that would be called a corner, and that's another thing. More on that later too. But this is called a cusp right here. And what makes it that is because the slope suddenly changes. It instantly changes at this point right here where x is -2. So -2 is a questionable point. What happens to the slope now is it goes from -2 to very positive. Very, very positive. So on a different layer here, I'm going to make drawings all over this in like yellow, or maybe this gold color, right? If I create a tangent line here, I mean, that's really steep. That's, in fact, the steepest point. Watch this. Okay, I'm just going to make a bunch of tangent lines. Now here, at that magical point, that's going to be 0. Okay, right there, that's 0, that one. And then it turns negative right there. You see that? That last little dip right there is negative. Let me fade that off so you can see that. Right there. See how that last one is negative. Now, if we have to put a graph on this first one that went up through here like this, very steep, and that's a positive slope. Let's just, again, let's not split hairs here. Let's just throw a number on that, because we know this is the steepest part, and it's going to become less steep, less steep, less steep, less steep, 0, and then turn negative. Okay? So let's call the first one maybe 5, positive 5, because that's a positive slope right there. We'll call that 5. So we'll come up here, and we'll put another circle, because again, we can't have 2 points existing like that. And that's going to be up here. And then this slope is going to get smaller. So at this point, maybe that slope isn't 5 anymore. It's obviously not as steep. Maybe it's, I don't know, 3. Positive 3. So here. So this line is going to extend down like this. My goodness. I think I hit Control S there. It's going to extend down like that. And then we will approach 0, okay, right here. And this is, of course, less steep. Maybe we want to call that, I don't know, 2. We keep going down, 2. Right here. So this keeps going. And in fact, this will basically become a straight line here. When this is 0, this is a very important critical point here. At that point where that derivative, where that tangent line is 0, that's where it hits right here. And you probably had that when you tried this. So this line here is going to extend down. I'm going to have to use my... Okay, that should be straight. I kind of got off there. I'm going to have to bold it up a little bit to make it look completely straight. But there, you know, that's going to happen. And then this last little bit here is going to turn negative. That's going to turn negative right there. All right, so this is going to continue down into the negative slopes down to this point here. Okay, so the derivative part, which now let me trace that in pink and make it look good. It's kind of a different color, isn't it? Let me go back over that. Okay, there's that. And then this goes from here down to about right there. Bold face that thing real good. And then something happens. This graph is going to break again because this slope, this last yellow line I drew right there, right where this thing is approaching this point, is negative. And that's represented here. And we would have another open circle right there. Because what happens now is this little piece of green line here is the, you know, if you think about it, the equation of that is y equals 4. That's a flat line at y equals 4. That little chunk, though, right, from here on is y equals 4. Now, I ask you, what is the slope of y equals 4? Well, tangent lines here are also flat, So its slope is flat. So we're going to have another open circle here, but in the right color, because pink will be our derivative. And it's going to continue to be 0 forever, because that arrowhead right there suggests we're going to the right forever. So this pink drawing is the derivative, f prime of x, of the green. And if this was confusing, it's only because you need to do several more examples. And this is confusing for everybody at first. But to answer the question now, let's answer this question. Where's the function not differentiable? There's a rule that I've kind of summed up in a sentence that says this. And I'm going to pause this and type it. Be right back. Okay, so I typed this out. And basically, boiling all this down, a function is not differentiable at the points where the function's derivative, the graph of the derivative, is not continuous. So when you have these breaks in here, get that off. When you have these breaks in here like this, here and here, those aren't continuous. It's continuous from here all the way down here, and it's continuous from here all the way over here, and from here all the way back this way. But at these 2 points here and here, it is not continuous. Therefore, it's not differentiable at those 2 points. So we could say, to answer this question, where x equals -2 and x equals 3. And that's where they're not differentiable. Have a good one.